All right, so last time we talked about the limit definition of derivative. We said a secant line is a line that cuts through a parabola twice, and you can find the equation of a secant line. The slope of the secant line is referred to as the average rate of change. But then if you found the line right at a point, that's called a tangent line. Tangent line touches a parabola right at a point. And you could find the slope of that line, and that's called the slope of the tangent line. And the big thing I wanted to get across to you is that the slope of the tangent line at a certain point is called the derivative. The slope at a point is called the derivative. For a while, we're going to call it the instantaneous rate of change also. So in example 2, it says, where is the instantaneous rate of change the largest? It's really asking what? Where what's the largest? The greatest slope. And how do you know if a slope is larger than another slope? Higher? More? What can you tell about slope? If you're just looking at a line, what can you instantly tell about the slope? Positive, negative. There's a good start. So if it's positive, that's going to be a greater number than a negative slope, right? And then if you're looking at two positive slopes, how can you tell which one's larger? Greater rise over run. Very mathematical answer. I would just say steeper. The steeper it is, the larger slope it is. So looking at these dots right here. Okay, just picking out the positive ones. Is A positive? Right here, yeah. Is B positive? What is it? Negative. And now I drew this. I meant for C to be 0, so we're going to pretend it's a slope of 0 going on right there. So by slope of 0, I mean if we drew a tangent line right there, it'd be horizontal. D, positive, negative, 0. Positive, and E is negative. So looking for the largest one, it's going to be between the two positive slopes happening here, between A and D. Which one's more positive? A. A is the larger, the steeper, so it is the largest instantaneous rate of change, the largest derivative. What's the next largest? D, the other positive one. So this one is what I would call very positive. This one was a little positive. What's the next largest one? C. It had a slope of 0. And now we're looking at the two negatives. We have B and E. So one of those is larger than the other. It's almost easier to think of which one is the smallest, meaning which one is the most negative number. E. E is the most negative number. And then B would go right there. It's negative, but not as negative. So if it asks you to compare instantaneous rate of change or compare derivatives, all you're doing is literally comparing the slopes at given points right there. All right, so we're going to find the instantaneous rate of change for this function at x equals 5. What that really means is find the derivative of this function at x equals 5. What that really means is find the slope of this function at a single point. The only way we know how to do this at this point and through test 1 is using the limit definition of derivative. Using the limit definition of derivative. I'm going to switch over to my PowerPoint real quick. Slide. Don't mention it, you're going to confuse everybody. Oh, okay, this is my broken arm attempt to teach blah, blah, blah. Okay, whatever. Here we go. So we're going to find the instantaneous rate of change. So you should be thinking, I'm finding the derivative. I don't know the shortcut, so I have to use the limit definition of derivative. So the first thing you should write down is the limit definition of derivative. Okay, so that's going to be the limit as h goes to 0 of f of x plus h minus f of x over h. This is something you got to know. So far in this class, you got to memorize one thing. You have one flashcard. On one side, it says, what's the limit definition of derivative? And you flip it over, and you should be able to quote this. One index card to study for your test so far. Well, I mean, you also need to know the whole Bobo bot and HRC thing. But are y'all with me? Okay. So whenever we want to take the limit as x approaches a number or as h approaches a number, what do we do in general? When you want to take the limit as x approaches 4 of something, what do we try first? plug it in. We try to plug it in, right? That's our first step. If that doesn't work, what do we do then? Factor, cancel, then we plug it in. Same thing here. The limit as h approaches 0. First, we're going to have to replace f of x plus h and f of x with what they equal. But then our very next step is we would really like to plug in h equals 0. But we won't be able to because it instantly causes the denominator to be 0. So we'll have to factor, cancel, then plug in h equals 0. So we're still doing the limit the same way we were. It looks like a little bit more complicated situation. So there's 3 parts to this. We have h on the bottom, which is just h. F of x, which is in blue, that was given to us in the problem here. Okay, so when we get there, we'll just do minus, and we'll just literally plug that part in. So f of x plus h is the part we have to find. That means in our function, everywhere there's an x, and there's 2 of them here, we're going to replace it with x plus h. So we'll write 100 plus 15, and instead of x, we'll put x plus h. Minus, instead of x squared, we'll say x plus h squared. Okay. Well, hold on a second here. So for the f of x plus h, I just took my original formula. Everywhere there's an x, I put in an x plus h. An x plus h. Okay. So I have f of x plus h. It's in yellow. Minus f of x. I literally just put in my original formula. Boom, f of x. I have a reminder here, don't forget the parentheses. So having taught this class a billion years now, mistakes I commonly see, first mistake I commonly see, people forget the formula is subtraction and they'll put addition. It's a subtraction form, okay? Second mistake I will almost always see in a class, people forget to put the parentheses. Why is that a mistake? It's going to mess up. Yeah, distributing your negative through, it's going to completely mess it up. Okay? So we want to be able to distribute the negative all the way through. So you've got to put those parentheses there. And so our very first thing we do is replace f of x plus h with what it equals. Replace f of x with what it equals, and h is still just h. All right. So at this point, we'd say we're taking the limit as h approaches a number. Let's try to plug the number in. Oh, we can't. It causes 0 in the denominator. So now we have to factor, cancel, and try again. The whole factor, cancel part is not as quick as it was earlier. Factoring this out is going to mean I'm going to have to multiply this 15 through to each of those. Right here it says minus this squared, x plus h squared. What do you do for x plus h squared? What do you have to do? Foil it. Going to have to foil it out. First, outer, inner, last. And then over here I just need to distribute my negative. So my very next step is to do all this little simplifying stuff that's going on. Okay? So what I have going on here is I have 100 plus, I multiply this 15 through. 15x plus 15h is right there. And then I waited on the foiling and I just wrote it out minus, and I just wrote it twice. X plus h times x plus h, because it was squared. And then here I distributed this negative. I said minus 100 minus 15x minus x squared, all over h. So there's 15x, there's negative 15x. So I'm going to cross those 2 out. There's 100, there's negative 100. So I'm going to cross those 2 out. So making my life a little bit easier here. So I'll go ahead and write this out again. So this is going to equal, and it leaves me with 15h, and then I foiled this. Okay, if you've got to go off to the side and do it, you can, but it's x times x is x squared, plus xh plus xh is plus 2xh, plus h squared. Okay. Look how I put that negative. I kept my negative in front with these parentheses here. Those are very important. A lot of people will FOIL this out without those parentheses. All right. Don't forget these parentheses again. Very important. We're subtracting off that whole thing. So my next step, I still can't plug in h equals 0. So notice this. Until I plug in 0 for h, I've not taken the limit yet, have I? So here I could not plug in h is 0. Couldn't take the limit yet. So I have to write that I'm still taking the limit as h goes to 0. Couldn't do it here either. So I still have to write, I'm taking the limit as h goes to 0. I haven't done it yet. As soon as I actually can plug 0 in, I don't have to write that anymore. Okay? But I can't do it yet. What do you think my next step's going to be? Can't cancel anything right now. Distribute that negative sign, yep. So I'm going to distribute that negative sign right here. So it'll be minus x squared minus 2xh minus h squared. Distribute my negative sign. Once I've distributed my negative sign, what do you think I want to do now? Cancel stuff. So I have a negative x squared and I have a positive x squared. So all I have left in the numerator, look at every term I have left. They all have an h in it. There's an h, there's an h, there's an h. I can't cancel, I can't combine, but they all have an h. So this means I could factor an h out of every single one of those terms. Why would I want to do that? Because then I'll have h multiplied on top, which will allow me to cancel. So this is what we just had. Okay, so I take what I have left, 15h minus 2xh minus h squared. They all have an h. I'm going to take an h out of each of these and put it right here, pull it out. And it leaves me with, if I take an h away from here, it leaves me with 15. Here it left me with minus 2x, and here it left me with minus h. Okay. So this was my whole goal. I wanted to factor an h out so it would be multiplied so that I can now cancel it. And why would I want to cancel the h's? So that I could plug 0 in for h without causing the denominator to be 0. So now I can cancel those h's. Okay. So I still haven't plugged in 0 yet. So I still haven't taken the limit yet. So I have to write, I'm still taking the limit as h goes to 0 of this function. But now, finally, after I've canceled, I can now plug 0 in for h. So that's my next step. I'll plug 0 in for h. Boom. And it leaves me with 15 minus 2x. Now, I'm not boxing an answer or anything because I'm not, since you're doing the limit definition of derivative, which took like at least 2, maybe 3 slides here, I'm not grading just your answer. I'm grading the whole thing. Okay? So instead of boxing an answer, I put these 2 little marks at the end. It's mathematical. It's called QED. It means you're finished with a long mathematical process. It's to let you know you reached the end. Okay? So this is right here, 15 minus 2x. That is our derivative. That is our instantaneous rate of change. Okay? Instead of putting 5, you might have thought, why didn't we put 5 in at the very beginning and just start doing it in the formula? On your online homework, it's going to say, find the instantaneous rate of change for this function at x equals 5. And then if you put a 5 in and did it that way, you hit enter, the very next question will say, find it again for the same formula at x equals 12. And so then if you did it the way where you plugged in the 5, now you have to do it all over again, plugging in the 12. Whereas if you just do it in general, like this, when you reach the end, for part A on the online homework, you plug in 5, there's your answer. You plug in 12, there's that answer. You plug in 9, there's that answer. Boom, you knocked them all out at once. Okay? So that's why I just showed you how to find the derivative in general. Now you can plug in x equals 5, and we would get the answer is 5. All right, so example 4. Is this in y'all's notes here? Okay. Epidemiologists. This is a little bit true example that I just happen to do every year. But epidemiologists in College Station, Texas estimate that T days after the flu begins to spread in town, the percent of the population infected by the flu is approximated by P of T equals T squared plus T. Okay. It says find the average rate of change of P with respect to T over the interval from 1 to 4 days. What does average rate of change mean? The slope of like a secant line. So the slope when given an actual 2 points. Average rate of change just means use your slope formula because you have 2 points. So we don't quite have 2 points yet. They gave us from T to T, so they gave us the 2 x values. How do we find the y values of the point? Plug them in. So that's what I'll do first here. So when t equals 1, if we put a 1 in to our equation, we'd get p of 1 equals 1 squared, which is 1, plus 1, which equals 2. And so our first point would be the point 1, 2. So I have to find my first y value. So when x is 1, y is 2. That's one of my points. I got to find the other one, so I'm going to take my 4. And I'm going to plug 4 into my equation. So when t equals 4, plugging it in, p of 4 equals 4 squared, which is 16, plus 4 equals 20. And so my second point is going to be the point 4, 20. So using our 2 points, we're going to find the average rate of change, or the slope, between 2 points. And so here our m, which is our slope, I did y2 minus y1 over x2 minus x1. Since I used the y value of 20 first, I had to make sure I used the x value that went with it first also. So I get 18 over 3, which is 6. So I get the average rate of change is 6. But this is a word problem, so all of your answers have meanings here. So we've got to think about what we're talking about. We're talking about T days after the flu begins, the percent of population infected by the flu. So, and rate of change means it's changing. So is it increasing or decreasing? It's increasing because it's a positive number. So it's increasing by 6% per, what's our time frame? But 6% per day. It's in days. So percent of population infected by the flu is increasing by 6% per day between 1 and 4 days. Yes, this is only true if it's between 1 and 4. So part B, the same exact problem. It says find the instantaneous rate of change, which also means derivative, which also means the slope at a point. Find the instantaneous rate of change of the percentage of the population of the flu with respect to t equals 3. So that means on day 3. So the only way we know how to find the instantaneous rate of change, the derivative, the slope at a given point, the only way we know how to find that at this stage in our calculus career is the limit definition of derivative. So the very first thing you should write down is what? The limit definition of derivative. If this is a 10-point problem on your test, you get a point for at least writing down the correct limit definition of derivative. So that's nice to know. Oh, and let me show you also what I did. I did write down the limit definition of derivative. There it is. But also when I have problems like P of t, my limit definition of derivative in my head is memorized with f, x, and h involved. And so I just changed my problem to be an f of x problem. So you don't have to, but if you're like me and you memorize this definition with an f and an x and an h, then you might change p of t to f of x. Instead of t squared plus t, it equals x squared plus x.
So on a test we can change
Yeah, yeah. And so then that will go more, whatever the word is, smoothly when I'm using my limit definition of derivative. So I have the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so before I can even try to take the limit, which means before I can even try to plug in h equals 0, I have to replace f of x plus h with what it equals, and I have to replace f of x with what it equals. Okay, so that is my f of x. When I get to that part, I'm just going to subtract that original equation. For f of x plus h, everywhere I have an x, I'm going to replace it with x plus h. And so instead of x squared, I have x plus h squared. Plus, instead of plus x, I have plus x plus h. So I just replace my x's with x plus h. Minus, these parentheses are very important. I want to subtract the entire f of x. So I want to subtract the entire x squared plus x. Okay. So all I did in that step was replace those two things, the yellow thing and the blue thing. All right, so my next step is I can't put h equals 0 in right now. I'd like to, but I can't because it would cause the denominator to be 0. So I'm going to have to factor, then cancel, then plug it in. The factoring part means up here on top, I'm going to need to FOIL this out. Over here, I'm going to have to distribute this negative. Right here, I could distribute this positive if I want to. That really doesn't change anything. It just means I'm going to take away the parentheses. So I wrote my x plus h squared out as x plus h times x plus h. Here, distributing the positive just took away the parentheses. And here, I distributed my negative signs at the end. Now, I haven't taken the limit yet, so it was very, very important that I write the limit as h goes to 0 in front of this. Okay? Again, if this is a 10-point problem, you get like a point for every time you're supposed to write it. So if you leave it off all 5 times, you miss 5 points. This is the whole point of this lesson, no pun intended. But the whole point of this is to get down what a limit is. So before I went on, personally, you can do this in a different order. You might want to FOIL next, but I personally would actually cancel my x and negative x right there because I always cancel anything I don't need. So there's my x, there's my negative x, they're gone. Now I'm going to have to FOIL this out. So first, outer, inner, last. Haven't taken the limit yet, so I have to write the limit as h goes to 0. Then I FOILed that out. Again, if you need to go to the side and do that, you can, but you get x squared plus 2xh plus h squared. And then I was already left with a plus h minus x squared.
Is that x squared plus 2xh plus h squared like universal?
If it's just flat out x plus h squared, yeah, it always comes out to that. Now the thing about these limit definition of derivative problems, even as they get harder, these are what I call easy ones right here. We've been doing polynomials. We did a polynomial, we're doing another polynomial. These are the easy ones, okay? We're going to have a medium, we're going to have harder. That just means longer and really long, not necessarily hard. But the great thing about these is in the end, if you do it right, everything cancels except for your h terms. So in the end, if you're stuck with some x on top, you did something wrong. You can go back and fix that. So right here, my x squared and my negative x squared cancel. So the only thing I have left in the numerator are my terms that have an h in it. That means so far things are going well for me. That means I can take an h out of each of these. I'm going to factor an h out of each of these. So I pull an h out of each. This one, when I pull an h out, it left me with 2x. Here, when I pulled an h out, it left me with h. And then this last one, when I pull an h out, a lot of people accidentally think it leaves you with nothing, so they put 0 there, but it has to leave you with a placeholder. So when you factor an h out of that last term, it has to leave you with a placeholder. Why? How can that make more sense to you? Multiply it back through. 2xh plus h squared. If there was a 0 there, we wouldn't have that term anymore. We need it.
Why did it become a plus 1 and not a minus 1?
It was already a plus h. So I pulled out that h and it stayed plus placeholder. So this was my whole goal, is to pull h out so it's being multiplied now. So now I can finally cancel it. And why do I want to cancel it? Because I want to plug h equals 0 into this problem. So I'm going to cancel my h. So I'm still looking for the limit as h goes to 0 for this function. And now for the first time, I can actually plug 0 in for h. So I'm going to plug the 0 in for h. That means I just took the limit. That little blue whoop-de-woo right there means I took the limit. I no longer have to write limit anymore. So what I have is 2x plus 1. That is my instantaneous rate of change. I'm finished with this particular step here. That's my instantaneous rate of change. That's my derivative. That's my slope at a given point. But it's specifically asking for at t equals 3 or x equals 3 since we changed it to x. So I have to put x equals 3 in there to see what that is. So at t equals 3, or x equals 3, we get 2 times 3 plus 1, which is 7. It's a word problem, though. So we were talking about percent population. It's a positive, so the percent is increasing on which day? Day 3. And so we say 3 days after the flu began, the percent of the population infected was increasing by 7% per day. Oh. All right. So when looking at a graph, we know when looking at a graph, we should be able to find a limit, because approaching from the left and right, you're approaching the same point. That means a limit exists. We know if it's continuous or not, because you can just pretend you're riding a roller coaster, and if you wouldn't continue, then it's not continuous. There's a third thing you're going to need to know for graphs. By looking at a graph, you should be able to tell if the function has a derivative at every single point or not. And there are 3 places where the derivative does not occur. What is a derivative? Instantaneous rate of change, but it's also the slope at a given point. So when it says the derivative doesn't exist, that means the slope does not exist at that point. So there's 3 places where this happens. The first place is when the function has a sharp turn or a corner point. It's called a cusp. If you look at your graph right here, oops. We got one occurring at x equals -5, that corner point right there. There's no way to have a slope there because it would like teeter-totter. We don't know how to draw a slope there. So there is no slope at corner points. If it's a sharp corner, no slope, therefore no derivative, right? So 3 places derivative doesn't exist. It doesn't exist. Sharp turns. The second place is if the function has a vertical tangent. So we know we have positive slopes, negative slopes. Horizontal line is a slope of 0. What happens if it's a vertical line? Undefined. The slope doesn't exist. No slope. That's what vertical tangent means. So if it's going along and all of a sudden, boom, it's a vertical line, there's no slope there. So there's no derivative there, because literally the derivative is the slope. So on this one, you're going along and at -1 here, straight up and down line. Okay? The slope is undefined. If there's no slope, there's no derivative, because the slope is the derivative. So derivative does not exist at sharp corners. Derivative does not exist when it goes vertical. And the third one's kind of obvious. The derivative doesn't exist if the function's not continuous. If there's a hole in the graph, there's no derivative, there's no slope happening there. Okay? If there's a hole in the graph or a break in the graph, there's no slope, there's no derivative. So on this particular one, we are going to list the x values where the derivative does not exist. It's called where the function is not differentiable. Right here, there's a word. We say it is not differentiable at that point. That means it does not have a derivative. In other words, the derivative does not exist. In other words, f of x doesn't have a derivative there. Okay. So reading from left to right, what's the first x value we come to that does not have a derivative? -5. So f prime of -5 does not exist because it's a corner point. It's a sharp turn. It's a cusp. Going from left to right, what's the next x value we come to that the derivative does not exist? -1. At f of -1, that derivative does not exist because it goes vertical on us. There's undefined slope. Where's the next place our derivative doesn't exist? 2. So that means f prime of 2 does not exist, and that's because it's not continuous there. So there's no slope if it doesn't continue. And where else would it not have a derivative? At 7. There's a hole in the graph at 7. So if there's a hole, there's not a point to have a slope at. So the derivative does not exist at 7. F prime means derivative. So we're saying the derivative does not exist at these places. Whoever I'm talking to. All right, so we're going to look at this next one. Find the instantaneous rate of change, which means the derivative, for this function. So at this point in time, we only know how to use the limit definition of derivative. So the very first thing you would want to write down so you get that 1 point on your test, the limit definition of derivative right there. So this is the limit as h approaches 0 of f of x plus h minus f of x over h. Hopefully you will be saying this little formula in your sleep. Okay. And we know the goal for limits is to be able to plug in the number. So we'd like to plug 0 in. Before we can even have a chance at that, we have to replace f of x plus h with what it equals. So that means everywhere I have an x up here, which there's only one, I have to replace that with x plus h. So I'm going to write 3 plus 7 over x plus h. That's how I replace it. And then minus f of x is just minus that function. So replacing f of x plus h with what it equals, I go to my function f of x and I replace the x with x plus h. So I just replace the x with x plus h. Minus f of x means I just subtract my original function here. Notice those parentheses, again, very important. Don't forget the parentheses. How come I'm what?
How come the parentheses are only on x and not on the...
Because there's a negative in front of them that I want to distribute. I could put parentheses around the first part also, but it's just a positive in front, so I don't need them. It stays positive. But the negatives are going to affect it because I have to distribute the negatives there. So now that I put those two things in, I would like to plug in h equals 0, but I can't. So this is where we factor, cancel, plug it in. So on the factor part, we have to do with the top up here first. First thing I would do, what's the first thing you would do? Anything? Distribute the negative, exactly. So distributing that negative sign, it gives me minus 3 minus 7 over x. All I did was distribute the negative sign in front of the blue part. Okay? And you may be staring at it like I have no clue what to do, but then you get a little excited because you're like, well, at least I can cancel those 3's, right? That's something. So that's what I'm going to do next. I'm going to cancel that 3 with that 3. Once you cancel your 3's, what we have left in the numerator is 7 over x plus h minus 7 over x. I need to combine them, but they do not have the same denominator. So what do I have to find? A common denominator. So they're completely different. This one's x plus h, this one's x. Okay, so my common denominator is going to be what I get when I multiply them together, x times x plus h. So the one that has an x plus h, it's missing an x. In order to get an x there, I'm going to multiply that part by 1. And that particular 1, okay, that's what I get when I cancel the 3's, is going to be x over x. So this one is missing an x, so I'm going to multiply it by 1. But the 1 I choose to multiply it by is x over x. I'm getting a common denominator. Minus the 7 over x term, it has an x in the denominator, but it's missing an x plus h. So I'm going to multiply it by x plus h over x plus h. If you multiply by 1, nothing changes. But I've got to get those common denominators going in there. So I multiply both parts by 1 to have my common denominators going on. Okay. So at this point, I have a common denominator in the numerator. I have a common denominator. So I have x plus h times x, or you could say x times x plus h. Either way, I chose to write x plus h times x. That's my common denominator. And then I'm combining, since it's the common one, I'm combining everything on top. So I have 7x minus, and then I put parentheses right here. So I'll be sure to distribute it. But this would be 7x plus 7h. But I got to be sure to distribute my negative here in a second. So I got a common denominator, so I put my common denominator together, and I'm combining the numerator part on top. I went ahead and wrote 7x minus, parentheses, 7x plus 7h. I'm going to distribute that negative on top. So now I have 7x minus 7h. So I had to get a common denominator, combined what I could. I can now cancel the 7x and negative 7x. Look at this h down here on the bottom. Ignore the top for a second. It's all divided by h. That's the same thing as dividing by h over 1, right? If you wanted to think of it that way. So dividing by h over 1 would be the same thing as multiplying by 1 over h. So hold on. Cross those out. Notice I've not taken the limit yet, so I'm still having to write the limit as h goes to 0. I have not finished. I have not plugged it in yet. But this time I did rewrite the bottom as h over 1. Because 3 is 3 over 1. 9 is 9 over 1. 4 is 4 over 1. Why do I want to think of it this way? Because I want to multiply by the reciprocal. Because when I multiply by the reciprocal, I'll see how I can cancel my h. So in my very next step, all I'm doing is flipping that denominator part, multiplying by the reciprocal. So this was my whole goal all along, because now, boom, boom, I can cancel the h. And as soon as that h gets canceled, I'm able to plug in h equals 0 to the rest of the problem. So once I cancel that h, it gets me down to this. I just have negative 7 over x plus h plus x. Now, finally, I can put a 0 in for that h, and it won't turn the denominator to 0. Here, it'll pop it up to the next screen. That's what it was just showing. Putting that 0 in means I no longer have to write the limit. The 0 went in for the h. So I just have negative 7 over x times x, which is negative 7 over x squared. All right. This is the problem we're on, right? Okay. So we want to find f prime of x. That's the derivative of f of x, or the instantaneous rate of change, or the slope at a given point. Okay? We want to find the derivative for this function using the limit definition of derivative. That's the only way we'll be finding the derivative on this test, the limit definition of derivative. And so these are like, I don't know, I haven't written the test yet, but like 10-point problems, say, and you got to show all your work. I'm not just looking at the answer. So you get 1 point for doing what? Writing down the definition of derivative. So we're going to write down the limit definition of derivative here. Boom. So the limit as h goes to 0 of f of x plus h minus f of x over h. Hopefully most of you got that in your head now. Again, things point out, it is h going to 0, not x. And it's a minus sign. All right, so I've got 3 things that I need to replace. Well, I guess h you really don't need to replace. But f of x plus h, I need to up here, every time I see an x, and there's 2 x's. There's one on top, there's one on bottom. Everywhere I see an x, I'm going to replace it with x plus h. Okay? So instead of 2x minus 5, I have 2x plus h minus 5. And on the bottom, instead of 8 plus x, I have 8 plus x plus h. So the yellow part here is representing my f of x plus h. Then when it just says minus f of x, it just means minus, put this exact function in. All over h. Things to be careful with. When you subtract off f of x, make sure you put parentheses around it, because we want to be subtracting off that whole thing. All right, so the ideal thing is when you're taking the limit as h is approaching a number, we want to put the number in. So putting 0 in for h right now would cause the denominator to be 0. Can't do it. So we're going to have to factor, cancel, try again. The factor part's going to take a bit of time here. Looking at the yellow part for factoring, if I multiply the 2 through, I'd get 2x plus 2h minus 5. Down here, if you distribute that plus sign, it just takes away the parentheses. Up here, not a lot I can do yet. I don't want to distribute the negative. A lot of people try to distribute the negative on top and bottom, which undoes it. You can only distribute it one way. So my suggestion is to keep your negative right where it's at until you get a common denominator. So on my next step, all I did was distribute the 2 across. So I distributed this 2x plus 2h. And then down here, I took away the parentheses because I distributed the plus sign. Okay, so at this point, we want to subtract these two terms, but the denominators are totally different. This says 8 plus x plus h, and this one says 8 plus x. We want to get a common denominator going on here. So if this were just like 8 and 5, common denominator would be 40. We'd want to multiply the first one by 5 over 5 and the second one by 8 over 8. Same thing even though we're talking about letters. So this one has the 8 plus x plus h. It's missing the 8 plus x. So I want to multiply it by 8 plus x over 8 plus x. Right there, 8 plus x over 8 plus x. The second one has the 8 plus x already. It's missing the other denominator. So I want to multiply it by 8 plus x plus h over 8 plus x plus h. So this is me getting common denominators here. Multiplying this side by 1, multiplying that side by 1. So once we multiplied by this common denominator, we now need to multiply through. Now this is like foiling, but on steroids here, because it's not like a binomial times a binomial. We have 3 terms going on here. So the first thing I'm going to do is put parentheses right there, so I know that I'm just doing the whole thing. Same thing on the bottom down here. Okay, so then I want to multiply. Now I'm going to put my parentheses there also. So I'm going to be kind of foiling here. I'm going to multiply this 2x to the 8. So I do this in pieces here. Hold on. 2x times 8, and that gives me 16x. Okay? So I recommend not writing this down 100 miles an hour because I'm going to walk you through it slowly. So 2x times 8 is 16x. Y'all with me so far? The next one would be 2x times x, which gives me 2x squared. So I'm done with the 2x. I'm going to move over to the 2h. 2h times 8 gives me 16h. And then 2h times x gives me 2xh. So I'm done with that one now. So I'm going to move over to the negative 5. Negative 5 times 8 gives me negative 40. And negative 5 times x gives me negative 5x. So I'm going to pause a second. I'm done with the left side. I ultimately foiled whatever it's called, foiled on steroids, all that out. All right. So then I got my minus sign. For some reason, this minus sign likes to disappear on people's papers when they're doing these long problems. Make sure you've got that minus sign, and then whatever's about to come, you're going to have huge parentheses because you're going to subtract off whatever's about to come. Okay, and I'm going to do it in parts with you here. So minus, parentheses, the first one is 2x times 8, which is 16x. And then I'll do 2x times x, which is 2x squared. Then we have 2x times h, which is 2xh. Okay, so now I'm done with the 2x. I'll move over to the negative 5. Negative 5 times 8 is negative 40. Negative 5 times x is negative 5x. And negative 5 times h is negative 5h. So I multiplied all the left, and then I got my big minus sign in the middle, and then I multiplied out all the right. You with me? Okay. Now look at my denominators. These are common denominators. They're the exact same ones. So what I'm going to do is I'm going to put those together. what I do here, I typically don't make a new line. I don't remember what I did on the PowerPoint. But I typically right above it distribute my negative sign and say negative 16x minus 2x squared minus 2xh plus 40. And I just distribute it all across right there instead of making a whole new thing. Again, I don't remember what I did here, so let's see. Distribute negative sign. Oh, yep, I made a whole new one for that one. But that's just me. You can do it right above yours if you want to. So all I did on this one was I put it over my common denominator. So I just combined them over my common denominator, so I have one denominator, and I distributed my negative all the way through. Okay. Again, if I were really doing this problem, I wouldn't write this all out again. I'd just distribute the negative right above it. Are y'all with me? Good thing about these horribly long, ugly problems is if you did it correctly, the only thing that's going to be left in the numerator will have an h in it. Okay, if you have terms that don't have an h in the numerator, you're doing something wrong. So we have 16x minus 16x. Then we have 2x squared minus 2x squared. 2xh minus 2xh. Negative 40 plus 40. Negative 5x plus 5x. So all I have left is the 16h over here and the 5h right there. That's all I have left. And that'll work every single time if you do this right. All you have left with terms that have h's in them. So if I add 16h plus 5h, what does that give me? 21h. 21h. All right. So we have 21h over all this. This h on the bottom is really h over 1, so instead of dividing by h, we can multiply by the reciprocal. And this is what we've been working up to. Now we have these h's can cancel. So as soon as we cancel those h's, we're finally able to take the limit as h goes to 0. We can now plug 0 in for h, and it will not cause the denominator to be 0. So plugging 0 in right there for h, I'm going to be left with, and notice I did not write limit as h goes to 0 this time because I just took the limit. I'm done with that. So all I have left is 21 over, that was 8 plus x plus 0, so 8 plus x times 8 plus x, which we will typically write as 8 plus x squared. We don't want to FOIL that out. Why, you might ask? When we start doing stuff with this later, doing the shortcut rule, not the long way, this will be the way we will want it and not FOIL it out because life will be easier, just trust me. So this is my long example of limit definition of derivative. All right, so it says sketch a graph of and find the equation of the secant line. So if we were to find the slope of the secant line, we could do that. We're given the function, we're given two x values. How would we find the y values that go with them? Plug them in. So we plug them in to get the two y values. So then we have 2 points. Once you have 2 points, you can find the slope, y2 minus y1 over x2 minus x1. But that's not all we're doing here. We're actually finding the equation of this line. So you don't really have to sketch it. I mean, you can if you want to, but you can just think this is an upside down parabola. So this is what it looks like. And there's 2 points happening here, and there's a line going through it. I'm not really going to be asking you to sketch it. I just want you to see what's going on from my example here.
Even on the test.
Even on the test. And so here's my graph, here's my function. Actually, you're going to need to sketch it for the next part anyway, so let's do that. Go ahead and go to your calculators. I'll give you a second to get your calculator out. Those of you who have your calculator. Okay, hopefully you've graphed before. If not, hang with me here. So go to y equals, up in the top left corner right here of your calculator, y equals. And in y1, you're going to type in 6 minus x squared. If this is new to you, make sure you type in the subtraction sign and not the negative sign. That's at the bottom of the page. And then there's an actual X button right around here that you use for your X. If you're having trouble, ask your neighbor. And then just to get a normal standard window going on for right now, hit zoom 6. Zoom is in the middle right here. Zoom 6, and that's a standard window. All right. So finding our y values by hand here. If I did f of -1, it'd be 6 minus -1 squared, which is 6 minus 1, which is 5. And so my first point is going to be -1, 5, which I have plotted right there. F of 3, 6 minus 3 squared, would be 6 minus 9, which is -3. So that point is 3, -3. So these are my 2 points, and I plotted that one there. And what I'm wanting to do is find the equation of the secant line. So the equation of it. So the equation of a line is y equals mx plus b. We can find our slope by doing y2 minus y1 over x2 minus x1. All right, so we did that, we got our 2 points. All right, so now we can find our slope. Our slope is y2 minus y1 over x2 minus x1. So I just did y minus y over x minus x. So I get 8 over -4, which is -2. So the slope of a secant line is -2. And remember, secant line means you have 2 legitimate points and it's cutting through the parabola twice. Okay. Once you have the slope, then in the equation y equals mx plus b, we can replace that m right there with a -2. So we have y equals -2x plus b. We just need to find the b value. And we can find that b value by plugging in either one of these points for x and y. There's an xy, there's an xy. We can plug in either one. So I'm going to just plug in the first one here. So I put a 5 in for my y equals my slope, which is -2, times the x, which is -1, plus b. So I just put my first point in. -2 times -1 is 2. And I can subtract that to the other side, and I'll get 3 equals b. So now I have the equation of my secant line to be y equals -2x plus 3. Okay, so this part A was an algebra question. You did this back in algebra. Given 2 points, find the equation of a line. That's what we just did. Part B takes the same problem and turns it into a calculus problem. It says find the equation of a tangent line. So a tangent line is a line that touches a parabola at exactly 1 point. So let's see what picture of that would look like. Well, I just have it graphed right now. But at x equals -1, it's just going to be plotted right there and have a line. That's a tangent line. So to find the equation of a line y equals mx plus b, the slope of the tangent line is called what? Slope of a tangent line. Derivative. Slope of the tangent line is called the derivative. Okay? Right now, the only way we know how to take the derivative is the limit definition of derivative. However, good news. If it's asking you to find the equation of a tangent line at a point, I will let you use your calculator because there is a feature on your calculator that will do this for us. Okay? Everything else we've been doing, there is no feature. That's why we've been doing it all by hand. So I'm very pro calculator. If we can use it, we're going to. Do I feel guilty? You're not doing this by hand? No, later on we're going to have extra variables involved and you have to do it by hand. We'll just learn it then. No need to overload you now. So I'm about to show you how to find the equation. This only works for when you're finding the equation of a tangent line. Okay, so you graph it in y1, which I've already done. And you did like zoom 6 or something, so you're looking at it. Everybody looking at it? Okay, if you don't have your calculator, you're going to really want to write this down. you're going to go to second draw. So you have to hit your second button, and draw is somewhere in the middle of your calculator behind program. So second draw, it's your program button. Are y'all there? The fifth one down should say tangent. You got it? Second draw, the fifth one down should say tangent. Choose that one, hit enter. That's what it's looking like. Okay. When you hit enter, it'll look like nothing's happened, and that's because nothing has happened. You haven't told it where to draw it yet. So once you hit enter, you have to then type the x value where you want to find the equation of the line. In this case, it's -1. So you want to type -1, enter. And it will draw the line for you. And at the bottom of your screen, it'll tell you the equation. So it draws the equation of a tangent line. And down here at the bottom, it says y equals 2x plus 7. Okay. Now, some of yours might say y equals 1.99999. Anyone? It will. And then some of you will say 2.000000001. We're smart people. We know it's 2. Okay, don't put 1.999. It's 2. Okay. So the equation's at the bottom of the screen. This is our equation of our tangent line. All right, so what I want to do, I've got to pull up something to write on.